The question is, suppose the demand function of a consumer is given by the equation P is equal to 80 minus Q, where P denotes the price and Q denotes the output. If price is being given as, that is P is equal to 60, we have to find out the consumer's surplus. Options are being given, we need to find out the correct option. Okay, so given the demand function is P is equal to 80 minus Q. Okay, this is our demand function. So let us first draw its graph here. Okay, we can solve this question without using the integration. So when Q is equal to 0, P will be equal to 80. So let us denote Q on the horizontal axis and price on the vertical axis. When Q, and let me write it here, when Q is equal to 0 in this equation, so P will be equal to 80. Okay, and this is downward sloping, obviously, because Q is negative here. So we will have a downward sloping demand function like this, and its price intercept is 80 here. Okay, now given this demand function, we are being told to find out the consumer surplus when price is equal to 60. Okay, and let us draw a line which denotes P is equal to 60. This denotes the price of 60. Okay, now what is consumer surplus? Consumer surplus is simply the difference between the price that the consumers are willing to pay for a product and the price they are actually paying for the product. Okay, and graphically in this case, the consumer surplus is simply the area which is above the market price and below the demand function. The area of this very triangle gives us the consumer surplus. So since it is a right angle triangle, we also need to find out this very intercept. Okay, so when P is equal to 60, okay, when P is equal to 60, when P is equal to 60, what is the quantity demanded? So in place of P we have 60. Let's write 60 is equal to 80 minus Q. So we get Q is equal to 80 minus 60. So Q will be equal to 20. Okay, when price is equal to 60, quantity demanded is equal to 20. Consumer surplus is simply the area which is below the demand curve and above the market price. So since this is a right angular triangle, its area is 1/2 of what is the base of this very triangle? It is 20. So we have 20 times height is equal to 80 minus 60, which is again 20. So we get consumer surplus, which will be equal to 2 ones are 2, 10s are 20. So we get 200 as the consumer surplus. The question is, if the average cost function is equal to, which is AC, which is equal to 25 minus 8x plus x square, x denotes the output, we have to find out the level of output where average cost is minimum. Okay, so given the average cost function is AC, which is equal to 25 minus 8x plus x square. Okay, now average cost will be minimum where slope of AC is equal to 0. Okay, what is slope of AC? Slope of average cost is simply the derivative of average cost function with respect to output. Okay, we set this equal to 0. That means the derivative of AC with respect to dx. First we need to find out this derivative. So derivative of a constant is 0, derivative of x in the second term is 1, so we are left with minus 8, and derivative of x square in the last term is equal to 2x by power function rule, and we set it equal to 0, which implies 2x is equal to 8, which gives us x will be equal to, dividing both sides by 2, so we will get x is equal to 4. So the level of output where average cost is minimum is in fact equal to 4. Question is, given demand function is Q is equal to 25 minus 4p plus p square, where p and q are the price and quantity respectively. What is the price elasticity of demand when price is $5? Options are being given, we need to find out the correct option. So given the demand function is Q is equal to 25 minus 4p plus p square. Elasticity of demand, and let's denote it by elasticity of demand is simply given by we have the negative sign first, then we have dq upon dp times p upon q. This is the formula for elasticity of demand. Okay, so first we need to find out when p is equal to $5, what is the quantity demanded. So we plug the value of p is equal to 5 in this equation. We have 25 minus 4, in place of p we have 5, plus we have p square means 5 square, it becomes 25 minus 20 plus 20 sorry, 4 5s are 20, then we have 25. Okay, so this becomes 25 minus 20 is 5, so we get here 5 plus 25, which comes out to be 30. That means when price is equal to $5, quantity demanded is 30. Next we need to find out this derivative, that is the change in the quantity demanded due to the change in the price, that is the derivative of this function with respect to p. Derivative of a constant is 0, derivative of p in the second term will be 1, so we are left with minus 4, plus derivative of p square is twice p. Okay, now we can apply the elasticity of demand formula, that is elasticity is equal to minus dq upon dp. So we have first minus, then dq upon dp is minus 4 plus 2p times p upon q, p upon q. Okay, now let's give the values. So elasticity will be equal to minus, when p is equal to 5, so when p is equal to 5, give the value of p is equal to 5 and q is equal to 30 in this equation. So we'll get minus 4 plus 2 into 5 times p is 5, so we write here 5 upon q is 30. So we get E will be equal to minus 2 into 5 is 10, minus 4 is 6 into 5 upon 30, which becomes 6 1s are 6 5s are, sorry, 6 5s are 30. So we get elasticity of demand is equal to minus 1. So elasticity of demand will come out to be minus 1. It simply tells us if price increases by 1%, quantity demanded will decrease by 1%. The question is, if the utility function of a consumer is u is equal to x raised power alpha times y raised power 1 minus alpha, x and y are the two goods consumed by the consumer, and u denotes the utility derived from the consumption of these two goods, we have to find out the marginal rate of substitution. Okay, so what is MRS? MRS is actually equal to the ratio of the marginal utility of good x upon marginal utility of good y. Let's write it capital here. Okay, and MUX means it is simply the change in the utility function due to the change in the consumption of good x, that is the partial derivative of this function with respect to x. So given this utility function, taking derivative with respect to x means the exponent of x becomes coefficient. So we have here, if I write it here, so alpha becomes coefficient, then we have x, and alpha is subtracted by 1 by power function rule. Y remains same as it is, as 1 minus alpha is the exponent. Okay, similarly marginal utility of good y, if I write it here, marginal utility of good y means the change in the utility due to the change in the consumption of good y, that is the partial derivative of this utility function with respect to y this time. Okay, this time the exponent of y is 1 minus alpha, it becomes coefficient 1 minus alpha, x remains same as alpha, and we have y raised power 1 minus alpha, and its exponent is subtracted by 1 by power function rule. Okay, now let's find the ratio, that is MRS. MRS is simply MUX upon MUY. Okay, MUX we calculated it as alpha x raised power alpha minus 1 y raised power 1 minus alpha upon Muy is this very term, that is 1 minus alpha. Then we have x raised power alpha, y raised power 1 minus alpha minus 1. Okay, now let us further solve this. If we do one thing, and if I have the space here, if I transpose x raised power alpha minus 1 to denominator, so let's first write alpha. So alpha, then we have y raised power 1 minus alpha. Transpose this y to numerator, it will get multiplied, but its exponent will change. So sign of the exponent sign will change. So if it is plus 1, it becomes minus 1. It is minus alpha, it becomes plus alpha. It is, if it is minus 1, it becomes okay minus it becomes plus 1. And by the same logic, we have here 1 minus alpha, 1 minus alpha, let me write it here. Then we have x raised power alpha. Transposing this term, it will get multiplied, but its exponent sign will change. So we have x raised power minus alpha plus 1. Okay, solving further, you can see, if I write it here, I don't have the space, MRS will be equal to, so we have alpha here, bases are same, we can add up the exponents. First this gets cancelled, then we have here, we have in fact y raised power 1 minus alpha plus alpha. Okay, alpha gets cancelled, we are only left with y in the numerator. And by the same logic here, what happens here, okay, we are left with this very term here. So we have x raised power alpha minus alpha plus 1. Again alpha gets cancelled, we are only left with x and 1 minus alpha. So this will be y upon x. This will be the MRS of x and y. Question is, the trace of the following matrix. We are being given this matrix and we need to find out the trace of the matrix here. Okay, so what is meant by the trace of matrix? Let me write it here. So trace of a matrix is actually, it is actually the sum of what we call principal or main diagonal elements. That is, given this matrix, its trace will be equal to, so we add the elements on the principal diagonal. So this very diagonal, and if I write it here, if we have this A, B, C, D, let us say we have the 4 elements here, this very diagonal is called the principal diagonal or main diagonal, and trace is simply the sum of the elements of the principal diagonal. That means we need to sum these very elements. This diagonal is called the principal diagonal, so the trace will be equal to 1 plus 0 minus 1, which comes out to be 0. So the trace of this very matrix will be 0. Next question is, if A is equal to 3, 4, minus 6, 1 is a matrix, the value of its determinant is, options are being given, we need to find out the correct option. Okay, so let's write the given matrix as, we have 3, 4, minus 6, 1. Okay, this is our matrix. Determinant of this very matrix will be equal to the product of the elements on the principal diagonal. This is called the principal diagonal. So first we multiply these two terms, that is these two elements, that is 3 into 1. So we have 3 into 1. From this we subtract the product of the non-principal diagonal elements. Okay, we subtract the product of these two terms, that is 4 and minus 6. So we have 4 times minus 6. Solving this, we get 3 minus into minus is plus, 6 4s are 24. So the determinant of this very matrix will be equal to 27. Okay, so given this 2 by 2 matrix, its determinant is simply the product of these two elements first, then we subtract and multiply the product of these two elements. Question is, demand function for a good x is being given as p is equal to 28 minus 5x, where p denotes the price, x is the output, and total cost function is, that is c is equal to x square plus 4x. We have to find out the profit maximizing level of output. Options are being given, we need to find out the correct option here. Okay, so let's write the demand function, that is p is equal to 28 minus 5x. This is the demand function, and cost function is c is equal to x square plus 4x. Okay, now profits maximized. Okay, profit maximization requires that we equate the marginal revenue of a good with the marginal cost of that very good. So what is marginal revenue? Marginal revenue is simply, to find out the marginal revenue, first we need to find out the total revenue, which is simply price into output, which will be equal to, so p is equal to 28 minus 5x, to this we multiply by x. Okay, so total revenue will be equal to 28x, since this x is multiplied to each of these terms, minus, then we have 5x square. This is the total revenue. Next we need to find out the marginal revenue. Marginal revenue is simply the change in the total revenue due to the change in the output, which is x here. That's the derivative of this function with respect to x. Derivative of x is 1, so we are left with 28 minus derivative of x square in the second term is 2x, so 2 into 5 is 10x. This is our marginal revenue. And what about marginal cost? Marginal cost is simply the change in the cost due to the change in the output. So this is the derivative of this function with respect to x. Derivative of x square is 2x, and derivative of x in the second term is 1, so we are left with 2. This is our marginal cost. Profit maximizing condition is that we equate the marginal revenue with marginal cost, which is MR should be equal to MC. So MR is 28 minus 10x, and we equate it with the marginal cost, which is 2x plus 2. So we have 2x plus 4 in fact. Okay, here we have 4. Okay, derivative of x is 1, so we are left with 4. Here we have also 4. Now transpose this minus 10x here and this 4 here, so we get 28 minus 4 is equal to 2x plus 10x. Okay, so 24 minus 4 is, sorry, 28 minus 4 is 24, and 10x plus 2x is 12x. Dividing both sides by 12, we will get x is equal to 12 ones are 12 twos are. That means the profit maximizing level of output will be equal to 2. If total cost function is c is equal to f of q, which is equal to 10 plus 15q minus 6q square plus q cube, find marginal cost. So what is marginal cost? Marginal cost is simply the change in the total cost due to the change in the output produced, and it is simply the derivative of the cost function with respect to q. Derivative of a constant, as we know, it is 0. Derivative of q in the second term is 1, so we are left with 15, minus derivative of q square is 2q, so 2 into 6 is 12, and exponent of this q is subtracted, so this is 2 minus 1, which is 1, plus derivative of q cube will be 3, will become coefficient, and the exponent will be subtracted by 1, so this will be the marginal cost given this total cost function. So simply the derivative of a cost function with respect to output gives us the marginal cost. The question is, the production function is being given us as q is equal to 18x1 raised power 0.2 times x2 raised power 0.1 times x3 raised power 0.7, where q is the output, x1 is land, x2 is labor, x3 is the capital. If total output is 9 crore rupees and inputs are paid according to their marginal productivity, then the share of land will be, options are being given, we need to find out the correct option. Okay, so given this production function, if I write it here, so output is actually a function of x1, x2 and x3, okay, which is equal to 18 times x1 raised power 0.2 times x2 raised power 0.1 times x3 raised power 0.7. We need to find out, and we are also being told that Q is equal to output produced is equal to 9 crore, 9 crore rupees of worth. We need to find out the input share of x1, that is the share of the land here. Okay, so here the exponent, these exponents of x1 and x2 and x3 actually shows us the output elasticities of, if the exponent of x1 is 0.2, it shows us the output elasticity of input x1, and similarly x2's exponent shows us the output elasticity of input x2, and same is true for x3. And we also say that these exponents show us the share of the each input in the total production. Okay, that means share of land will be equal to what we call here the the output elasticity of input x1, which is 0.2, which is in fact the share of the land in the total output. Since it is equal to 0.2, then we need to find out the share of the land will be equal to, so this is the output elasticity of land here, so share of land in the total output will be equal to 0.2 times the total output produced, which is equal to 9. So 0.2 into 9, it comes out to be 1.8 crore. Okay, so exponent of each of these inputs shows us the share of the input, percentage share, and since total output is produced as 9 crore, then the share of the land will be equal to 0.2 times the output produced.